further. Thank you so much. In my pitch, I would like to say that fortunately or unfortunately, the soils which are used for farming, they are regarded as the central or federal property, and usually it is not supported by any mapping and is not supported by any archives. Some means that soil within one field would differ in terms of their properties, especially in the south. Would come F4, and this is what I will highlight, exemplified by the research which we did in Krasnodar. Actually, the traditional crops in that region were the grains. After that, they decided that they have to promote soybeans. I took certain crops, certain species, certain technologies started setting, but actually soybeans cannot reach its potential level. Typical of the breeding farms and companies, and they started thinking why this happened. When we were invited, we resorted to the conventional technology of the assessment of the environmental hazard, collecting data, bringing a problem assessment of hazard, assessment of the scale, etc., etc. After that, we followed all the steps. We made a morphological and physiological map of risks for planting and growing soybeans. We made a list of risks, and after we assessed the risks, it turned out that very often the risk factors related to the soil and environmental properties are most important, number one. After that, as far as the soil and environmental conditions are most important, we deep dived into that. And we did some field studies, and we identified that there is one factor there, the availability of a compacted horizon. And in the Krasnodar region, this horizon is not just compacted by the agricultural equipment, but it has some other natural features, meaning that it is dense, and after the impact made by the agricultural equipment, it actually compacts further. For soybeans, this would be very limiting factor because you have to develop their root system, and the compaction actually limits this factor. We identified that this horizon is present everywhere, and within one quarter of fields, the structure of the soil pattern is various. Uneven redistribution of moisture results in wetting of the seeds, and very often the agricultural equipment cannot be used to treat some types of soil and lateral development of the root system. Soybeans actually this way actually has its root going down up to 1 meter for the watering, for the irrigation purposes, and in that case the roots will develop laterally. And we see that maturity also is not even, and harvesting also actually is done not the same time within one field. And when part is already mature, another part actually is not mature yet, and we see fading, and we lose part of soybeans. We broke down the fields by whether they are appropriate for growing soybeans. 5 types of landscapes the upper parts of the slopes and drained slopes with the compacted soil, also the lowlands and other types of horizons. We classified certain features, we made a set of maps, proposed certain definitions. This is one of the legends of the map, which has its own code. The slopes, compacted horizon, different forms of relief, and we got a GIS system which included more than 558 different fields as a separate entity, with a total territory of 52,000 square kilometers. Most of the work was done on the central part. A few words about the climate. We made some focused maps without the use of the horizon, with the use of the compacted horizon, and for dry conditions and for the wet conditions or humid conditions. As I said before, this horizon acts as a kind of a membrane. For instance, during the humid years, it prevents the penetration of water into the lower aquifers or horizons. And during the dry years, it acts as a reverse membrane. It prevents the moisture from going up, and if the roots did not penetrate that layer before the drought, then it will get no water, no moisture. We built also certain maps which may help us to reshape certain fields, meaning that we can detach parts which contain that compacted horizon, or the one which doesn't comply with the necessary conditions. We can reshape those fields, the areas which are marked in red, and we can use that technology just changing the structure of the fields. What the system includes? It includes a comprehensive assessment of the soil and climate risks, the assessment of their biometric properties, homogeneity and non-homogeneity, assessment of the fields by quality, and certain field studies, and updating of the farming system. It was shown that, generally speaking, even if you do monitoring, if you look at the type of the climate which you have in that year, it turns out that if you use some agricultural techniques, you may address these risks and improve growing of soybeans there. Thank you so much. The spatial differentiation of the fields, presence or prevalence or absence of the horizons. Is it done based on the field studies, or how did you identify these compacted horizons? For this part of the fields, mainly, we used the field studies, so it was mapped manually. We had several field trips, and as far as the accuracy of the images was quite good. We got the data about wetting of the seeds, and does Russia use minimum or zero treatment of the soil? And will your territory increase or not? Well, no till and minimum till or tillage actually is something that we use. Russia is vast in its climate conditions. we use the so-called minimum tillage. And no till or zero tillage, this is what we use where it is justified. I have a practical question. So the in-field studies, actually, you met the cuts digging also using the excavators. We use shovels, also we use drilling. And actually we had full-fledged cross-cuttings and some dig-outs up to 60 to 80 centimeters. So this is something you can dig out up to half a meter. This is we did using shovels or spades. Well, actually, this is a private farm. We cannot use our tractors there, especially when we did most of our studies. Part of the fields were already seeded. And the final question. Tell me, please, this screen or screening horizon. Actually, this is the plow cushion. It depends on the anthropogenic factors. How you take into consideration the man-cost factors, or the fields marked in red. This is the satellite imagery or what. So the fields marked in red mean that these fields can be reshaped. We can reshape its structure, avoiding the rectangular shape. We just can cut that in half. Or, in essence, then the owner will take a decision whether he or she wants or not. Thank you so much, Alexei. One more question, if I may. The final one. Remote sensing. Which remote sensor you are using? So that's balance it and Naprimolis. Landsat. So there is a 50 meters range. For a more detailed data, what was the equipment, actual erosion in southern Siberia dynamics for the agricultural period, current state risk soil protection models. My presentation was made by 4 authors, 2 soil scientists and 2 morphologists. The agricultural lands in Siberia stretch up to 4,000 kilometers, and this is a territory with very sophisticated processes, that's Siberia. And without going into further details, we may say that tillage and other types of agriculture can be found even in the prehistoric period of time, because we discovered certain irrigation channels, but the local population was very much dissatisfied by the massive tillage. This is the data from 2003. Agricultural land account for 55 million hectares. Out of them, half of them are tilled already, and about 9 million are subject to different processes such as washout and deflation or wind erosion. And therefore we set up a network of stationary institutions or stations led by the Soil Institute from Novosibirsk, our scientific center of Siberian branch in Irkutsk. And this is the combination of soils which we have in terms of the plowland. In the central part of Russia, you may see the forest types of soils. Krasnoyarsk region has mostly the black soil and steppe or gray and forest soils and hazelnut soils. In the upper part of the slide you can see the shrinkage of the plowlands in Siberia. Buryatia is head of the list. They retained only 20% of the plowable lands after the economic crisis and depressions. So our soil scientists mapped the changes which occurred to the soil and their properties this way. So this was entailed by the anthropogenic or man-caused degradation of soils. Also, in every detail we studied the post-androgenic restoration of soil, a restoration back to the forest type of soil. This area, as you see, in terms of geomorphology, we have sloped types in the eastern part of Siberia, and this shows the stationary items or facilities there. In terms of the washout, we did a very profound study of the processes there in West Siberia. This is about the washout done by the melting processes. Our institute investigated into the rainfall or storm washout. Also on the plowlands we also studied the washout erosion, and we have to proceed from the local points to the spatial analysis. That's why we did the test at our stationary facility or polygon, where we can study the soil erosion using the methodology proposed by the Moscow State University. They are our good friends of ours. Unfortunately, I don't understand why they are not present at that conference. So the rates which we have measured and the calculated rates are very close, and therefore further on we proceeded with the spatial assessment of the potential washout to cover big territories and agricultural enclaves. We use the catchment approach or the basin approach. Nazarovskaya Kamskaya catchment area, this one. So the second process. This is about the gully or ravine erosion and deflation. We see that the modern climate conditions facilitate the expansion of that deflationary process. We did such districting, did some study on the desertification of the lands, and we use many parameters in our study. It's worth mentioning that today we see the end of the decade proclaimed by the United Nations as the decade of fight against desertification. And certainly I could deep dive into Baikal catchment area, but the most difficult situation there has cropped out here because they have different types of erosions. Push the wrong button. So they are interchangeable, meaning that posing certain danger to the soil all the time. And this drawing shows the rainfall accumulations, and for instance the United States used that on purpose, and here we see the rainfall accumulations in Selenga catchment area. It decreased somehow, and it helped our soil to get restored a little bit, get rehabilitated, and now we see a new stage of more efficient agriculture and farming. And finally, I would like to say that we have made certain regional models, bear in mind how intensive those processes are. In Siberia, three main models are being used. The Khakkaiskaya model, which prevents the rainfall washout, the protection against the wind erosion, and the Baikal model, which protects against both the washout and the wind erosions. Last year, we made a trip to Altai, and we saw how Altai model works. And we were impressed very much by the fields, which are in a very good shape. Certainly, we cannot but admire that. Another picture, how different crops are being planted in Khakassia, so they are using the same approach. And the Baikal Lake catchment area, pictures taken from drones, and you may see that the movement of sands and wind processes are quite active. This is in the estuary of the Barguzin River. Pictures taken last year. Again, pictures taken from the drones. You may see that immediately the slopes are being tilled, and due to the precipitations, this is what happens. And as an alternative, I'd like to share this my impression. We visited Normandy. We attended one of the biggest conferences on that. This is how they protect the soil with the linen. We made that visit back in 2013 with Anna and saw that with our own eyes. As for the top priority objectives are concerned, they coincide with what has been discussed at that conference today and yesterday. Thank you so much. Thank you so much. Question? Quick question. After lands were privatized, the road erosion is very much propagated. Do you have the same thing here? Yes, this is true. And this is something we have to take into consideration to fight against that. Certain measures are being taken. It's very difficult to fight against the road erosion. So once actually, if we speak about the ground roads, earth road, dirt roads, and especially in the Baikal catchment area. I have another question. 1980s, the Erosion Protection Institute has developed very feasible measures to fight against erosion. And after the user cycle lapsed, some of them are no longer feasible. So can you provide your own recommendations? Because what you presented originally in the 80s. Well, all those measurements were done in 1980s. But after that, we did monitoring. So we do not do that monitoring on a large scale. We are using the aerospace and satellite images, actually. One presentation alone cannot give you the full picture. And we managed to prevent erosion in Buryatia and in the Baikal catchment area. which where only 20% of the previously plowable land is left, and we restore forest, etc. But certainly we have to pull our efforts together. I invite all the geomorphologists to make friends with the soil scientists. We have to pull our efforts together. And the conditions were quite favorable. So these in Buryatia now I'm working here. And so I actually walked the whole territory there, so I'm dealing with trees and shrubs myself. I saw such serious consequences after the collapse of the USSR, just desolated lands full of some weeds, and at the moment only the weed is there.
I represent the academia. I study those processes, and I think you should refer your question to those who manage the land. I think you should talk to the administration. In France, there is a geomorphological service that has sufficient authority, and it can put the farmers' activities under control. I represent Eurochem company. Every year we perform over 200 various experiments and tests using different types of fertilizers, and we deal with fruits and other crops. In our work, we use agrochemical analysis data. We take soil samples before we start our experiments. We do agrochemical analysis for vegetation, water, leaf formation, soil, and so on. We do agrochemical support throughout vegetation periods. This is something we offer to our customers, our farmers, and major holdings. A few words about the issues we encountered in the course of our work. What are the 5 major mistakes that our farmers commit when they manage fertilizer application? Well, farmers mostly take into account NPK. They are not aware of any other nutrients. Very often they emphasize these 3 key components. Yet, the shortage of calcium may dramatically affect the quality of products. The next mistake is that our farmers do not do any analysis of soil or water or plants. Once every 3 or 5 years, farms do agrochemical analysis of soils just to get some subsidies, some preferences. But after that, having received the results of the analysis, the farmers do not change their farming patterns. So we recommend that the soil and water should be regularly checked and analyzed to manage minerals application properly. Third, farmers use too much fertilizers. This is true for smaller farms, because larger farms do cost-benefit analysis and they want to save on fertilizers. But unfortunately, farmers sometimes apply too much fertilizers. There is an old saying that nothing bad will come out of an attempt to apply the good practices. Well, that's wrong. Now, they apply fertilizers in the wrong time. That's the next mistake. Nitrogen is applied at the wrong time, or potassium is applied improperly, or some micronutrients are not applied at the time that would fit the development stage of the plant. And the last error, all the farmers use the same fertilizers. I mean, they're used to certain fertilizers, and they use the same fertilizer time and again every year. And gradually, ground starts to accumulate either phosphorus or potassium, and yields drop because a certain component starts to affect the access to other components. We stick to international rules, and we support the 4R concept. We are to properly select the fertilizer formats. Then we are to know the appropriate time for application. Then the rates of application. We have to know the application rates given your expected yields. And finally, we are to know how exactly we're going to apply the fertilizers, where we're going to use drop irrigation or leaf feeding, dressing, or any other approach. But again, it all is based on the pH analysis. Now, this is a soil map of the Krasnodar region. We are located in the south of Russia. This is the southernmost spot of our region. Now, the soil composition is very diverse. We have Chernozems, we have loamy soil, we have meadow Chernozem. Yesterday, we visited the tea plantation, and an agronomist said that pH of soil varies around 3.5. Now, we have soils in the western part of the region where pH rate is above 8. In the coastal area of Gelendzhik, pH rate is above 8 as well. Now, there are some soils, the majority of soils are neutral, about 6 to 7. And again, the soil map is very diverse. The same is true for nutrient contents. Now, this is a brief list of our crops, and here are some numbers for you. Now, we have over 3.6 million hectares of land under crops. Well, winter wheat is the predominant crop. We have 5.5% of the total area under this crop for Russia. Then we have barley, corn, and we account for about 20% of the total Russia area under this crop. We produce rice. The Krasnodar region is the only region of Russia that produces such sort of rice. We have sugar beets, sunflower, soybean, potato, vegetables. I mean, you can grow anything here, any crops that humans consume. Now, the average yields are shown here. We boast one of the highest rates, one of the highest yields in Russia. As you can see, here are some numbers in terms of yield for winter wheat, barley, corn, rice, sugar beets, sunflower, and soybeans. Now, as to the application rates, we sell a lot of fertilizers in this region. We sell phosphorus-based or nitrogen-based fertilizers, mixed fertilizers. Normally, farms use nitrogen-based fertilizers. And again, here's a breakdown by crop. So a lot of nitrogen is used for those crops by our farms. But farmers tend to forget about potassium. Our soils are rich in potassium, and thanks to this, over the past 20 years, we've been able to maintain fairly high yields. However, virtually no potassium has been applied over the period. But I mean, for say sunflower, our farmers do not apply a lot of potassium, although a lot of potassium gets washed away from plant roots. Now, nitrogen-based fertilizers, liquid carbamide, ammonia mix, ammonia and carbamide. These are the most demanded types of fertilizer. The share of nitrogen-based fertilizers exceeds 50%. In other words, our farms emphasize the use of such fertilizers. What are the issues with the nitrogen application? The global nitrogen consumption is over 77.5 million tons per hectare. About one half of this amount gets evaporated. Some 11 tons are mobilized, some 18 tons are washed away into bodies of water and rivers. We produce a lot of nitrogen-based fertilizers, and we are very much concerned with this issue. We're concerned with those losses. At the moment, we play with various nitrogen inhibitors, and in fact, this nitrogen inhibition topic is something that scientists have been working on for decades, and by now, we realize that one of the best inhibitors for, say, carbamide would be NBPT. We call it UTEC inhibitor. Now, in this country, we launched two facilities that produce UTEC carbamide with ureases inhibitor. One facility is located in our region. The key issues here are as follows. When carbamide is applied, it gets affected by the ureases ferment produced by our soil microorganisms, and a lot of gas gets generated, ammonia gas. Now, to neutralize this process, we add inhibitor to each granule of carbamide. And then the granule turns yellow. Carbamide normally would be white, but with this inhibitor, the granule becomes yellow. It's very easy to tell from other granules. We can reduce losses by a significant amount to some 35%. Now, the inhibitor inhibits decomposition by 2 or 3 weeks. Now, the total nitrogen loss can be reduced by half. UTEC carbamide is to be used for any crops. Well, obviously, we emphasized rice because this is a crop that uses up a lot of water, and it is produced on rice checks. But our data over the past 2 years suggests that UTEC inhibitor is very efficient for regular field crops such as corn and winter wheat, rice again. What else? Yeah, I mean, these are the 3 major crops. And some words on the application experience. Now we compared the UTEC fertilizer with ammonia, and we got an increase of 400 kilos per hectare for corn. For rice, we reduced the nitrogen application amounts, and thanks to inhibitor, instead of 4 times, we can apply nitrogen only once, and we reduce losses dramatically. This is a case of winter crops, winter wheat. We apply the same amount, and our experience suggested that we managed to dramatically reduce losses. These are the yields that are quite normal for this region. We also did some studies for winter rapeseeds, rice. Uh, for rice, we applied fertilizers at the same time when herbicides were applied. So one-time application was sufficient to last until the end of the vegetation period. We also did some research for potato. We applied fertilizer for potato. A lot of farms use irrigation systems to produce potato, and nitrogen losses may be very high there. Well, there are a lot of experiments that we've done, and we've proven that this type of fertilizer is affordable and is effective now. Those of you who visited farms would know that carbamide smells bad. Now, our UTEC carbamide does not have any smell. So a person can stand next to a pile of carbamide and there is no smell at all. So this is it, I guess. And now your questions, if any. Or perhaps you want to try this fertilizer in your farms. Please go ahead. Feel free. Okay, questions?
Что говорите, это правда, 100%. Но кроме
Macroelements, for instance, we have to take into consideration the physical and chemical properties, biological factors, and then we may determine how a man may interfere in order to get good yield and high quality yield. Cannot agree more. This is certainly very important. Do you work with the soil scientists in order to take a comprehensive approach to that? Now, we are more dealing with a mineral fertilization. We have our own agrochemical lab, but in terms of the biological activity of the soil, we are not dealing with these issues which you have listed. Yes, please, more questions. There is some potential there. I know that in the headquarters in the central institution, actually there are some works on that. I have another question about UTEC carbamide. You have similar effect to the acid and alkaline soils. We use that in Krasnoyar region, so these are alkaline soils, and we didn't test that in Sochi, so probably this is something we could do.
Thank you very much for your presentation. I'm very keen to follow. I was keen to follow your presentation. I just want to have one question. You told us that the soils in this region are very
В регионе очень разные, различаются от места к месту. И на самом деле вы говорили про показатель кислотности, что pH был достаточно низкий в одном месте, потом высокий в другом месте. И, соответственно, вы используете одни какие-то питательные вещества, а не другие, НПК. И, соответственно, показатель составит менее 40%. А вы используете какое-то удобрение, УТК, и вы сказали, что это позволяет повысить урожайность. Итак, как это повлияло на урожайность? И, может быть, каков был вклад, соответственно, вот этого UEC, потому что в большинстве стран, особенно в Африке, скажем так, показатель этот больше 20%.
Очень много информации, уже потерял нить.
How does that contribute to the increase in the yield? Well, I'm not sure, but we did some tests using nitrogen fertilizers, and we may save up to 10% in terms of the nutrients which we introduce. We can assume that 10% which evaporate, they are retained, so we can save up to 10% of the nitrogen loss, and at the same time the yield is the same. Question. I will speak not as the soil scientist, but rather as a crops scientist. Do you select the crops you're working with following some market analysis or any other approach? For instance, Vir grows 60,000 of samples everywhere, including 3 sites in Krasnodar region, and we invite everyone to study the reaction of the plants to mineral and non-mineral nutrition. And our main objective is to generate revenues. So we take the most popular, the most profitable for the farmers, but also we cooperate with all the R&D institutes. When I was a student, I visited Bir. Is it Uspensky region or which region? Gulkevичский district region. Yes, I saw your giant collection. And if you want, certainly we can do something altogether. PPP, public-private partnership. So let's get back to the erosion. When we speak about erosion, this is a kind of a process. The erosion process, which on the one hand is determined by certain factors, but on the other hand, it impacts the landscape and different components of the landscape. At the moment, I got an impression that mainly the soil erosion science focuses on identifying the connection between the factor and the processes. And when we speak about agriculture, about the food security, we have to move to other links of the chain, how it affects the soil, conditions of the soil, how the eroded soil change their fertility, and how it all affects the yield and the quality of the produce. In my presentation, I would like to highlight the erosion processes and the connection with the soil degradation. 2 main questions I ask: which methods we use in order to get the information about the soil erosion? Can we trust that information? And secondly, is the digital simulation, digital modeling, an alternative to the monitoring of the soil erosion? So the current monitoring system of the soil erosion has certain drawbacks. And there is a big database accumulated, but still we are doing monitoring over the last 50 years, and we're using the old style, very conventional methods. I will not deep dive into that. You know probably that how the monitoring is being done. And this is a very spacious mesh of cuttings. Then we draw the contour maps. We identify the erosion, and then you make an agricultural types of lands maps and develop certain recommendations. That's a real-life example. How Belgorod Agricultural and Chemical Service works with lots of cuttings. But we see how these contours are being done. So they are done manually by the experts, so you may draw that differently. But it is important for the farmer and for the future yield that it is quite accurate. Simplicity, this is the main advantage, and disadvantage is that it is very subjective, very biased. What is also not good about the modern system of monitoring? So there is some area of knowledge which is 100 years old, and over the last 50 years we have accumulated a lot of data. But the available monitoring system doesn't use this data. We fail to bet on those results, although the mathematical modeling can be used in order to somehow map the factors, the data, etc. Really, the knowledge base develops very fast. I have rendered an example of several articles specifying different erosion models. There are more than 100 erosion models. 82 publications were made on that. Back in the USSR, the erosion modeling was on the rise until the perestroika period, and probably we were even ahead of the rest of the world. We even developed recommendations on the basis of the erosion modeling, but after the perestroika, the developed nations started doing modeling very actively, but in Russia we no longer use that. Why there are so many erosion models, dozens of them, hundreds of them? Because we don't have a versatile model. And there is a big problem about that. People confuse that, they improperly use the models, going beyond what they allow for. There are certain algorithms, the lifespan being estimated. These are different models, the scale of the object, etc. I will not deep dive into that to save up time, but if a question arises, I can provide you with more information. Some modeling becomes trustworthy because models are validated and the models become better, and you can check their quality. A couple of examples, if I may, how we may use practically the erosion models. The most outstanding example is the one for Europe. The dynamics, due to the change in the policy and management, what changes took place. So we spoke about carbon emissions at the global level, etc. The erosion models use mainly is done at a global level, but not at a regional level, or it would be connected to the climate change. There is a list of publications which show that over the last 20 years, more and more scientists are connecting or attributing the soil erosion to the climate change, and the number of publications skyrockets. What is so important about that? You were speaking about the ambitions of the agriculture. We have to use these models at the level of big farms. Unfortunately, such works are quite few In the 2 remaining minutes, I will show our achievements, how the erosion models can be used. It can be done very simply. You can take just any model, calculate the washout for that territory, and then you make this mesh of cuttings for the monitoring purposes. I do not know whether you can see that clearly or not, but as an erosion scientist, I see that this mesh is quite spontaneous. It is not very helpful in assessing the soil erosion. We did another step forward, trying to connect the erosion data with the monitoring data. And we came up with the idea to use several plots, land plots. We took several hundreds of samples where we know the erosion rate, and we try to connect that with the mathematical modeling. Therefore, we calculated the chances of erosion on this or that pixel. We made an extrapolation and we got the rate of erosion in every pixel. In close cooperation with Belgorod Chemical Service, we checked our maps with the maps prepared by them. So seemingly they are the same, but it is not true. There are lots of areas where there might be some exaggerations or underratings. The main advantage of our approach is that these areas were identified not by experts but automatically using certain algorithms, and such deviations would depend on the slope. And so the local experts, they underestimate the erosion on the steep slopes. And the last slide is quite interesting about the retrospective erosion analysis. When assessing the soil erosion, it's very important to bear in mind the history of the soil use or land use, and we digitalized the maps of the last 300 years, and we modeled the washout. So please look at the cartoon, so the abandoning of the serfdom, then 1917, the after-war period of time, 1985, and finally the modern situation, the current situation. The acreage of tillage decreased dramatically, and so the washout also decreased, and this is something which you cannot assess using only the monitoring. So can we trust the information about soil erosion? I don't think that the erosion data is hard to reach and should be verified. This is conclusion number one, and conclusion number two is the digital modeling solution to that, or an alternative to that. Partially this is true. It can be done at the regional level, and secondly we can do that in order to assess the dynamics and trends, and this can be used by the auxiliary industries which do not need any accurate data. Digital models can be used at a large scale level for certain big farms, probably. Thank you so much. Thank you.
The models are better today. If you validate with some field data, the results which you get from validation and from the motors are getting closer than 20 years ago. And are the sets for validation today better and more representative than 20 years ago, or it is more or less the same?
Very much. For instance, we use the digital models of the relief, and for instance, the use of drones are very helpful. We can take very accurate pictures of the relief. I failed to mention that we did that in Bashkiria, which can boast micro relief, and actually we used the grid with the mesh of 30 meters, made a map of 1 by 10,000, and this model also takes into consideration the accumulation, and it means that result was very good, of a high quality, including the accumulations in the lowlands. So the input data improved the outcomes very much. Yes, please. Thank you so much. Thank you for your contribution. I have the following question. We have lots of mountains, and to record the eroded areas, that's one thing, but can your simulation help us in recording and mapping of the eroded area in order to identify exposure, vegetation, structure, and the curvature of the slope? So in that case, it would be very helpful in order to develop some anti-erosion activities. Actually, sitting in the bus going to the tea plantation, I thought about that. So it's not only that the steepness of the slope and the fact that the soil contains a lot of gravel that matters, but the erosion model is aimed at the black soils, not the gravel, for instance, soils. But, for instance, the Chinese are spearheading these efforts. This is a big problem for them, and they try to develop that. I do think that in some period of time we'll get some appropriate result. So I'm not dealing with the mountains. And the last question by one of the previous speakers, we can allow that. Are there any limitations in using your comparative assessment or estimate for different types of soils? Because it is well known that the morphological method to identify erosion doesn't work for the ash clay soils, it doesn't work in Siberia. As for the mountains, the simulation or modeling might be regarded as one of the alternatives. You may just make one map using some conventional methods, and you use mathematical modeling to do another map and to check whether you have the same data or not. So it would be
at our institute, because this session is related to Chernozems and to, let's say, black soils. And this, we have quite a lot of experience with that in Slovakia, because we have less area with Chernozems. In fact, the less is coming from throughout all northern Eurasia, from England and Belgium to Germany, Slovakia, Poland, Ukraine, Russia, Kazakhstan to Mongolia and China. And there is a lot of things which are in common for these soils. So maybe some examples from Slovakia would be interesting also for you. Our Chernozems are not very well developed. They are about 50 centimeters of mollic horizon. In some areas we have only ochrid horizon and BT horizon, so that's like some luvisol. And the eroded land on arable land is usually the mollic horizon is transformed by erosion to ochrid horizon, and in fact the boundary is completely sharp. The accumulations can be, this is one about 110 centimeters, but we have up to 4 meters deep accumulations on some small valleys, because this material is really coming in big quantities on the foot slopes and in the small periglacial valleys. This is example from Belgium. They have in fact luvisols on less, but we see almost no rills here, but subsurface flow is making tunnel erosion. It is saturated all over, and down below the slope there are big tunnels, and finally they are collapsing. So erosion is a big problem on less and in Chernozem areas. We have a lot of methods for measuring, like conventional erosion plots, hydrological methods for suspended sediment loads, all kind of rainfall simulators in laboratory, in field, volumetric methods, geodetic methods, and one of them is also fallout radionuclide methods. Yeah. These are just examples of few. These are my fields in Slovakia, which we have been running in 90s. That's our hydrological profiles running in 90s. These are example of my colleague from Tsukuba from Japan, of big, nice erosion plots, erosion pins, simulators. This is big rainfall simulator in Japan, and some, I believe this is in Canada. It's from one colleague. So all these methods have some advantages and disadvantages. It's difficult to discuss now because that would take a lot of time. Each method is different. Each method should be discussed for a long time. But fallout radionuclides has some special advantage that you are working retrospectively from the time when you are sampling to past. And you have all processes involved in the land where you are sampling, including tillage erosion and eventual wind erosion, if any. And also you can work for different methods because we have several fallout radionuclides. We can make several points, so we are getting a part of erosion rates, also some special distribution. The most commonly used radionuclides is cesium-137 with 30 years half-life. Much more difficult is lead-210 with 22 half-life, and beryllium with 53 half-life, 53 days. So this is very good for short-term and event-based research. Apart of that, earlier there was used, first of all was used strontium, but this was not very popular, and now they are trying plutonium. It is very good, but the problem is that the alpha spectrometry is much more difficult than gamma spectrometry. When we have measuring of beryllium and cesium, it's very easy because energy which they emit is very high, so 400, 600 kilo-electron volt can be measured by any gamma detector, while lead is much lower energy, 40 kilo-electron volt you can measure only with very sensitive gamma detectors. The origin of fallout radionuclides is very special. Cesium is coming from nuclear weapon tests. The emission was spread to all over stratosphere and relatively homogeneously falling down. Then have been some special events like nuclear power plant accidents like Chernobyl or Fukushima. Beryllium is natural. It is created by cosmic rays and falling to the surface. Lead has quite special origin. I will come to that in a minute. Cesium, the biggest fallout was from 1954 up to 70s, but the maximum peak was, one was in 59, but much bigger was in 63. This is kind of scheme where we can see also more about the lead. We have radon coming from rocks. This is decaying to, radium decaying to radon. Radon is gas. Partially is decomposing in the soil to lead, and partially it is evaporating to atmosphere, decomposing to lead there and falling down. So lead-210 we have in whole soil, but in topsoil we have more because we have the one which is created in the soil and another one which is falling down. This is the precipitation, the fallout of bomb-derived cesium is depending on precipitation. We have much more on the northern hemisphere, much less on the southern, because most bomb tests have been in northern Pacific or north of the equator, and the exchange of of air masses through equator is relatively small. These are the two peaks of the cesium fallout in bomb period. One peak of Chernobyl here, and these are the same situation for southern hemisphere, so the input was much smaller. That's the same, in fact. The Chernobyl accident brought much more cesium than bomb-derived cesium, so in areas which are affected cesium, the calculation of soil erosion is completely different, but it is possible to calculate. This is another map of contamination by Chernobyl, contamination by Fukushima. In principle, all Japan is contaminated, but this is again the story of the lead 210 creation, beryllium creation, and this is the principle of the method. We have flat area where the fallout radionuclide is strongly bound to soil colloids, so it is moving further only with mechanical processes. It's not leached or taken by plant too much, or little bit but not much. On the slope we have a decrease of the quantity of cesium compared to flat area, and on the foot slope we have increase because of deposition. So when we see, we are in fact sampling undisturbed reference site and the study sites, and when we see on the study sites decrease, that's the erosion, where is increase, that's the deposition. We can calculate, this is the same scheme, but a little bit more demonstrative, this deposition, erosion, and reference value. The difference is also in arable land and non-cultivated. In non-cultivated, there is an exponential distribution decreasing because of bioturbation by mesofauna and this kind of processes. It is decreasing slowly. Here we have plow layer, which is more or less homogeneous, and very little below. This is in the arable land. These are some cases. Typical exponential relation can be sometimes reduced in the top because the leaching little bit exists, but not much. This is the plow layer, and this is accumulation. In accumulation, sometimes this values is smaller than the original value of topsoil because there is accumulated material which already is from more eroded places, so it contains less cesium. Sampling can be done by hand corers, but people are propagating usually these very heavy motorized machines. You need several persons to hold it, and it is hammering by vibration to the soil, and the cores are then extracted and taken by kind of equipment, and then the cores are extracted and can be analyzed. If you want to make depth distribution profile, they can use scraper plate, which are scraping soil by 1 or 2 centimeters increments. You can use also a portable gamma detector in field, but then of course you don't have one profile, but you are measuring some average of some area around. Samples are dried, grinded, sieved, and especially we need surface, so how big was the core, and we need bulk density to recalculate for areal inventory. Sample measurements by the high purity germanium gamma detector, before there was germanium lithium detector used, is quite easy. Here is the peak of cesium at the 660 kilo electron volts. It's very easy to detect because there are not other nuclides in the spectrum too close that can be confused. And when we have cesium data, we are using some kind of models, and there are two different concepts for undisturbed soil, which has this exponential decrease, and for arable land, which has homogenized mixing of cesium in the plow layer. So these models are several of them. For cultivated land, proportional models and mass balance models. There are several versions, and for non-cultivated depth distribution and diffusion, this is wrongly written here, diffusion and migration model. So like here, diffusion and migration model. Sorry, this is, the proportional model is very simple. You just compare the quantity of cesium on eroded, non-eroded, and accumulated side. You don't need too much parameters for that. Mass balance models try to incorporate other parameters. For example, when you have plowing, every year, if some cesium is, some part of plow layer is removed, a certain amount of soil from below the plow layer is mixed to the plow layer, so the concentration of cesium in plow layer is decreasing. So every year, the smaller quantity of cesium represents the same quantity of eroded soil. So this is consideration for this model. This model is considering also the first two have been taking a year 1963 as an input of cesium, and this model is using also the time distribution of cesium fallout. So this is the most developed model. We have another one, mass balance model 3, which is incorporating also tillage erosion and needs detailed climatic data, which usually we don't have, so we don't use it very often. For the undisturbed side, we have the profile distribution model is in fact counting the distribution, but not temporary dynamics of the fallout radionuclide income. And this one, diffusion and migration model, is calculating the time dynamics. The models are developed for Excel macro, so you can just put in the boxes your data and you get your results. It's very, very simple and convenient. Here I show few maps, how to visualize the data, and these maps are showing with 3D pictures that erosion is not so simple, and all small changes in the relief are in fact are resulting in very complex patterns, and sometimes the accumulations can occur also on the slopes and on places which we would not expect. Fallout radionuclides you can use also for chronology of sediments. This is from Romania. This peak is 1959. This beginning is 1954, when there was first cesium occurring in atmosphere, first peak of bomb cesium, second peak of bomb cesium, Chernobyl peak, and the time when the sample was taken. So you can recalculate these 4 periods per year, how is changing the dynamics of the sedimentation. I have few data from my sites. We had 2 sites in Slovakia, Bohunice. This is typical example that for all transects, the cesium is decreasing from the plateau to the slopes, increasing in the valley bottom, again decreasing to the slopes, and increasing to the second valley plateau. So we can make some maps or 3D models. The same method used on the more sloping sides with higher values, with similar but more complex distribution. The final results we have been comparing with other methods used by erosion plot measurements in Slovakia and by hydrological methods. The second method, which I mentioned yesterday, apart of cesium or fallout radionuclides, is this compound-specific stable isotope analysis of C13. In the watersheds, we have different ecosystems or different land uses, and they contribute they have different C13 signatures. So, in fact, if we want to see how much sediment we have in the river or in the water reservoir, we can, by mixing model, we can identify from which part of the watershed it is coming. Apart of fallout radionuclides, I have few examples of erosion mapping with remote sensing. What is a good advantage is that in less areas with Chernozems, the erosion patterns are contrasting colors, so it's very easily to map from any remote sensing media, even black and white, aerial photos, black and white, satellite images. You can map by, you can use vectorization by hand, or you can use some mathematical calibration, mathematical classification of images, and we have been trying to apply the method.
Excuse
for
me,
some
but
large
it's.
and
I'm sorry,
finish.
absolutely no
Okay,
time
this
more.
is exactly what I have to tell you. Thank you.
Thank you so much, but we have not really time for question. We'll try to ask them.
For about a decade has been central in many discussions, yet the progress of this methodology in Russia has not been as illustrious. Thank you very much for the invitation. When I came to this event, I realized that the majority of the colleagues have known each other for many years, for a long time, and they interact very actively. Perhaps I can spend about 30 seconds to introduce my university, the Kazan Federal University, one of the oldest universities in this country. This year we celebrated 250 years. We have about 50,000 students, 12,000 staff, 9,000 international students. We have a network of institutes dealing with science, and we are part of this circle. We also teach humanities because we are a classical university. We have 6 chairs at my institute, and colleagues from at least 3 chairs deal with soil fertility very closely, including the chair of soil science. In fact, this chair was established by Turin, and I think you would know the name. We have a chair of applied natural resource management, landscape ecology, weather scientists. We offer bachelor's and master's programs. And just to follow up on yesterday's panel discussion, I put here a number of new courses, cross-cutting courses that we offer. And those courses we offer to soil scientists, and here we deal with digital mapping, the employment of remote sensing techniques, and so on. Now let's get back to the topic of my presentation. The loss of fertility and restoration of fertility are 2 major issues, and one of possible solutions is the use of so-called unconventional fertilizer, long-term fertilizer called biochar, or pyrochar, as we call it in Russia. Now, this substrate is a product of pyrolysis. It's a high-temperature treatment with no access of oxygen. It's a well-known process. Pyrolysis is normally used for vegetation waste. We used chicken manure for our purposes, and we attacked 2 issues simultaneously. That is waste disposal, and all the major holdings now will have to engage in this because significant fines are imposed in case manure is not disposed of. And we produced biochar in the course of the process. Why chicken manure? That's because it contains a lot of nitrogen, and we get very good fertilizer that has potassium, uh, phosphorus and nitrogen. Now, this is a long-term effect fertilizer and nutrients not put into soil very quickly within a very short period of time. Instead, the penetration of nutrients into soil is protracted over some time. This, among other things, helps to ensure carbon sequestration. Now, pyrolysis is a well-known process, yet the technology that would allow to produce high-quality biochar is not very well known. Now, we realized this when we started to look for pyrolysis units, and we realized that the majority of those units deal with quick pyrolysis when waste disposal is the ultimate objective, and nobody cared as to what this pyrolysis reaction would result in. Now, we designed our own units, our own pilot units, to produce biochar. And here are some pictures of these units on the top of this slide. Hopefully you can see those pictures. Now, this unit can operate round the clock, but it has to be loaded and unloaded, just a regular reactor. But by now we've learned how to ensure continuous operation of this unit. The thing is that chicken manure is generated in vast quantities, and the unit should support a very high rate of throughput. Now, we use different temperatures. We played with different peak temperatures, different time for the manure treatment, and we realized that the optimal temperature regime would be 400 degrees. If the temperature is higher, we get ash without char. If the temperature is lower, the resulting product is too toxic. Now, on the right-hand side, there are some pictures that show you that the porosity may differ depending on the temperature. Now, in addition to toxicological studies, in addition to the studies of the composition and distribution of components on the surface of the biochar, we did some lab tests. And we wanted to confirm whether we picked the right temperature regime. And we also wanted to understand the application rate for this new fertilizer. We got a lot of information, a wealth of data. We put together a huge database, and based on the outcomes of the biochar properties studies and impacts thereof, we came up with a detailed description of how this biochar affects biochemical soil properties, toxicity, functional activity, and so on. We looked at respiratory activity, metagenomic analysis, the microbe composition, and all these studies confirmed our initial guesses. Indeed, 400 degrees proved to be the optimal temperature for biochar production. Yeah, I missed one slide. Here we go. Before we started our lab tests, we thought to ourselves, okay, fine, we know how to produce powdered biochar. You know, powdered fertilizers are very hard to apply, and the existing technology is obsolete and outdated. So I wanted to identify new technologies to facilitate the application. Now, pyrochar and biochar contributes to biological properties, but since biochar is highly porous, we could add phosphate mobilizing microorganisms or some other microorganisms that might suppress phytopathogens, thus contributing to crop health. We played with all of this. We wanted to set up a consortium. We wanted to see whether microorganisms would interfere with each other. We looked at how such consortia could be built. We wanted to see how we could immobilize the microorganisms. We wanted to see whether they would preserve their activity and properties. And we also looked at the storage aspects. I mean, how to store the fertilizers so that the activity remains on sufficient level. We also wanted to see if we could produce this fertilizer in granules. Yes, indeed, we are able to do this, but there was one complication. If it's just pyrochar, there are no issues with granulation. However, if we add microorganisms, we cannot use traditional granulation techniques when high temperature is used. Therefore, we wanted to find some granulating techniques and some binding substance. We used real-time PCR methodology. Svetlana, I'm sorry, there's another aspect. I wanted to increase concentration of biogenic elements. Well, it doesn't work. However, iodine modification produced some good outcomes. And again, we did lab tests. We used small plots with barley and wheat. And one important thing we realized was that biochar does change the structure of microorganisms, but does not change their activity, and this is good. It means that there is no negative impact on the microbe community, unlike mineral fertilizers. And here I give you a bar chart that reflects the outcomes of our microorganisms tests. And here are some field experiments. Even at the small plot experiments, we obtained a fairly significant yield increase, and yet we realized that granulated or powdered fertilizers do not produce vastly different results. And here are some pictures of our experimental plots, all the way from planting the crops down to the application of fertilizer and so on. Now we used a precision farming technique to apply our fertilizer. Our soil scientists know how to do this. They know how to produce interpolated maps and in addition, we know how to produce layered geo soil systems. Thank you very much. This is it. Thank you. Thank you for your presentation. Very interesting, very exciting. My question is as follows. Now, biochar. Do you get biochar from sunflower? No. As I said, for this experiment we used chicken manure. But we can use any crop residues or animal waste to produce biochar. Well, we used sunflower residue to produce biochar. And we also used sunflower oil as an additive. Do try. It will give you very good results. Absolutely. In addition to animal breeding waste, we have some waste generated in the course of oil, vegetable oil production. Indeed, we can mix this vegetable oil with chicken manure, and this would indeed give us very good results. Thank you. It's good that we don't have any live broadcasting, otherwise we would have been fined for blatant advertising. Now, let's get back to the erosion issues. You know, whenever we have erosion, the products of erosion end up in bodies of water. That's why I'd like to ask Vladimir Grabarnik, please tell us how you clean up the water. This is a most relevant issue. The more intensive farming techniques we use, the greater the pollution is. Well, thank you very, very much. Thank you. As suppliers to our business, the more intensive farming techniques you use, the more customers we get. And mind you, we use bioremediation to clean up water. We fight water blooming. Now let us introduce a new term, ecostrophe. Unlike catastrophe, which is a one-time action, ecostrophe is something that accumulates over a period of time. This is something that we observe routinely but don't pay attention to it. Now this ecostrophe today is happening in front of our eyes, and it has reached a critical stage. I'm referring to the need to preserve water resources and bodies of water. Now, ecosystem of bodies of water gets destroyed to a large extent thanks to the activities of humans. And this results in eutrophication, this results in blooming and contamination of bodies of water. And in fact, the bodies of water are dying, and they can no longer be used either for economic or recreational purposes. In fact, the water is no longer potable. Now, the intensive farming techniques generate phosphates, nitrogen, which serve as food for cyanobacteria. And this results in very grave consequences. Here are some calculations made. I observed about 1,500 of closed bodies of water in Russia. And my observations suggest that if, say, production of mineral fertilizers grows 7% per annum, the total area of bodies of water subject to eutrophication grows exponentially. As of today, we see that such bodies of water as Lake Baikal and the Lake Victoria in Africa, the Lake Erie in the U.S., and Taihu Lake in China are all subject to eutrophication and blooming. Blooming will be a major issue for developing countries, where potable water is taken from surface bodies of water. Now, in many of our partner farms, blooming results in loss of fish, and besides, water becomes toxic for people, for animal. Now look, I'm not a scientist, I'm a business person. I can see this, and I can realize that this is a major issue indeed. Something that is already present, but we're reluctant to see. Now, getting back to my calculations, at least 90% of fresh water, what is a water contaminated with cyanobacteria. Within the next 10 years, blooming will affect 100% of bodies of water, and not just in Russia, but globally. We should not fight nature, we should help our nature to clean itself. Back in 1992, the UN Convention, Agenda 21st Century, called for developing a technique, environmentally friendly technique to clean up bodies of water. Mr. Bogdanov managed to address this already in 1994. Strain was developed and registered in the early 2000s, and over the past 10 years, we've been employing industrial technology, commercial-grade technology to produce those strains and employ them. In fact, in 2017 in Florida, the governor of the state introduced state of emergency due to blooming of water. Well, in fact, we can do the same in Chelyabinsk, in Nizhny Tagil, and in the Baikal Lake area. We claim that Baikal started to bloom this year. No, this is not true. Baikal has been blooming during the past 4 or 5 years. And I think this, to a large extent, has been due to this infatuation with nitrogen-based fertilizers. The technology that I'm talking about is very much relevant and is efficient. We used our technology in Crimea. It took us only 16 days to eliminate blooming. If this strain is applied properly, the quality of water immediately goes up. We used chlorella, but thing is that the rest of the world uses a different type of chlorella. We use plankton chlorella, and it's a mini algae. It prevents cyanobacteria from spreading, and it also produces a number of chemicals that can be very beneficial for the quality of water. Now, we have about 100 days of sunshine per year, and given this, we apply about 0.6 tons of chlorella per annum, and this quantity produces some 30 tons of chlorella. And this is something that living organisms consume willingly, and toxins are eliminated, and water becomes absolutely clear and transparent. I think I should wrap up. The technology is very efficient, but as I said, we should help our nature. Look at how well a business person is at timekeeping. No, don't go away. There are some questions. That's a very good example of an innovative approach. See, Vladimir visits universities, research institutions, trying to win support from them. Yeah, I'm looking for scientists. I'm looking for scientists who would be interested in dealing with cyanobacteria. There are some to deal with this. Okay, thank you very much. Thank you for your presentation. I wonder, we have a river, the Volga River, and every year I observe this river blooming. I wonder if you have done any studies. We are a business. we're a company. We try to encourage the Timiryazev Academy to join forces with us. We just observe. We have technology in place. The technology is comprehensive, is efficient, and it does not work.
The privilege to speak in front of you. I will be brief. So the agronomic concept in Russia and elsewhere in the 20th century rested on the use of chemical fertilizers, mineral fertilizers. But this practice resulted in the fact that at the moment we all see environmental and economic problems caused by such technology. Moreover, when using that technology, the so-called price disparity arises, and very often these would be the farmers who would suffer from that. In order to address that situation, we'll understand that we can use the conventional technology which is being used over the last 50 years, but it will not bring any good fruits. That's why people developed a new trend, the so-called organic farming. What advantages are there and what disadvantages are there for the bioorganic agriculture? Such a movement was officially developed in 1997, and it was promoted by such countries as Germany, France. It actually promotes the refraining from the use of chemical agents and organic fertilizers. The organic products have to be certified as such. In Russia, we also have organic products certificates. In that respect, certain principles were developed, which you may read from the slide. The main one is refraining from the use of the technologies of traditional farming or conventional farming, which do exist at the moment. In Russia, this trend is enshrined in the laws, but this question is still not solved fully. It's being debated and discussed, and is only in its infancy. Let's have a look at the situation in terms of the dynamics of the farming lands which are being used for organic products growing. Over the last several years, the acreage of such land plots increased 4 times, according to the research data. So let's have a look at the distribution by the continents. Most of the organic land plots are located Most of these lands are located in Australia, Oceania, and less organic land plots are located in Africa. This slide shows the share of industries and consumption of the organic products. We see that the main productive mainly the organic products are being produced and consumed in North America, in Australia. The figures are quite modest for Russia and Africa. That's why, summing up the situation, I can say in a nutshell that this area, this field is probably a trendy one, but it has certain disadvantages. The bioorganic farming results in huge consumption of power and land. Organic farming and its main vulnerability is about loss of productivity and yield. Less productivity and less yield. I can support that with the figures, though these are the comparative figures of the conventional farming and the organic farming. We can see that the average yield in conventional farming is 1.52 times better than in case of an organic one. Second thing, as concerns the use of chemical agents. So natural poisons or synthesized poisons still remain poisonous. And that's why. And this is a very controversial issue for organic farming as well. Second thing, once we touch upon animal husbandry, organic farming also needs the types of products that they grow for animal husbandry. Until now, we don't have clear-cut and convincing facts concerning the use of organic products, whether they're useful or not. We have not obtained any ample data that could support the idea that the organic products are better than non-organic ones. Mr. Glebov, you have exhausted your time. So let's keep that slide on. I'll try to be very fast. So the main co-authors are present here. Mr. Tomurzbek Jancharov is present here, Ivan Vasenev is present here, and Mikhail Kurashov from Barilla Company is not present here, but he's open for discussion. On the export potential of Russia, how we can help it to get boosted, especially using the black soils. Black soils can boast high fertility, and the durum wheat is very helpful there. So it means that we can improve the efficiency of the soil use. Why we resorted to Barilla Company? Because it is the biggest pasta producer. They need durum wheat. They are ready to produce it there, but it turned out that we don't have any production of the durum wheat. Durum wheat accounts only for 5% of the overall wheat. It is more costly, so it means that this is a very good thing for investment exporters. exporters are from North America, and there is some niche for Russia to jump onto the market, but Russia exports much less than Kazakhstan. We have to take advantage of that potential. So there is a potential for that product there. We have registered more than 50 grades of durum wheat, but we have no understanding where, in what area it would perform better than anything else. So the main prerequisites, advantages and disadvantages are listed on the slide. Let me highlight the last one. The necessity in environmental systems to support the high quality production of high quality durum wheat. Why we focus on that region? That's Volga, Middle Volga region, and Urals, because actually this is where durum wheat would be more advantageous than soft wheat. Actually, soft wheat may get you more money, more returns. Does Russia really have a potential for that? We are showing to Barilla partners that there is an enthusiast who is producing durum wheat for 7 years already, and the quality is quite high. These systems are to support decision making using the production models are there. The system is not being used in Russia. We need data, and we are short of lengthy climate and other monitoring data. And actually, we are lacking the 30-year-long monitoring data, and especially amid the climate change, it turns out that the data accumulated is outdated already, is obsolete. The main problem is related to these precipitations and humidity. Back in along with Ricardo Valentino, using MCC as a computer in Russia, we published a model which shows that along with the temperature rise, there is a rise in the precipitations, and so it means that this is good for the durum wheat. So what seasonal changes we have? Well, let me draw attention to the following. Increasing the amount of precipitations, the period when the durum wheat actually it has to blossom by June, but the amount of precipitations decrease. Can we shift the period? And once we shift that by 5 to 6 days, we may increase the yield 20%. Actually, some experts said that they followed the Easter celebration and never were mistaken. Look at the last decades. 2018 showed a dramatic decrease in the precipitation. It also decreased the yield, but improved the quality. Samara and Saratov see a different situation, something we have to take into consideration. So the seasonal dynamics in terms of temperature. Look at that once we actually get from perennial to from the average figures to perennial figures, multi-year monitoring data, then the dynamic becomes different. We have to be very accurate, otherwise we will lose credibility in the eyes of the farmers. We need a systemic approach. We spoke about online demonstration of the results. We have to do everything online, including issuing the recommendations. So comparison. Two adjacent or neighbor regions, Samara and Saratov, but they have seasonal changes in the yield and changes in the quality. 4 grades in terms of the yield. Look how big fluctuations are between the regions. I'm working for more than 30 years in the black soil territories, and this is for the first time that we reached some success in Orenburg when mineral salts actually were applied to the soil. But this year, actually, the conditions are good in order to survive through the winter. This is something which we have to take into consideration when supporting the decision making, when issuing certain recommendations. We are not interested in the yield alone, but we also are interested in the quality. It was a surprise for some of our colleagues that there might be such fluctuation in terms of pH, 1.5 or 2 times fluctuations. So it looks very similar to what you may see on the map, but sometimes there are big fluctuations. Secondly, we are interested not only in the yield but also in the quality. Usually, it works from bottom up, what you identify, and you use the main components method. So the reverse phases of the seasonality and it means that not only the climate which may contribute to the yield, but also the soil. And look, we see the decrease, but what are the features of the soil? So this is something which affects the quality of the soil. Very often, the soil features are more pronounced than the climate ones, and all the countries are now interested not only in quantity but rather in quality, because the higher the quality is, more expensive it is, and you can sell that at a profit. When we spoke about the decision-making support, what we started this is the agricultural and climate stations, and certain features of the grades. You start with the slopes and then you end with the soil. And Alexei will show to you a more advanced system, the one which we may showcase. And according to the multi-year monitoring, we may distribute the temperatures, we may distribute the precipitations, and what yield we may predict. This situation differs from region to region, and probably you can foresee the situation much better in your own farm, or you may do some seasonal predictions. So there are certain limitations, the precipitation limitation and the soil features limitation at the moment. The framework system, which is proposed for, which is designed for the farmers, has to be updated. But our cooperation in that respect can be of use. And now let me pass the floor to Alexei Yaroslavtsev from my chair. Does it work? Okay. Just on the fly, on the fly. So this is a presentation about two labs. Something which they have in common is that the labs, although one is dealing with the agricultural sites and the other deals with the urban sites, so they are involved in the monitoring. So this is the turbulent pulsations method, the method which helps us to get the IPCC reports, because this is what we got from the towers. In order, this data is used in order to measure the balance of carbon. In Chernozem Academy, we have several of such towers, and one of the experiments which I'd like to showcase here is that once, 1 year, we did the measurements in Kursk and on the territory of Chernozem Academy in Moscow. But in Kursk, it was a farmer who does organic farming, so he actually does seeding, and he doesn't do anything about that. He was just lacking money, but Chernozem Academy has the state-of-the-art technologies, maximum fertilizers. And the difference is huge in terms of the climate, in terms of the soils. But what we have as a result? Despite the fact that due to the climate conditions, the amount of carbon consumed by the biomass was much bigger in Kursk region. It turns out that the big amounts of mineral fertilizers used by Timiryazev Academy, actually it resulted in more losses of carbon compared to Kursk region. But we're speaking with the practical application of IoT technologies, and you cannot put towers on all the fields. And this is about using microscope to drive nails into the wood. You need something simple and cheap, which can be given to anyone and can be used for what we spoke about before, the appropriate use of technologies. So we have to develop certain technologies for that and recommendations. We need a technology which would be cheap, which would be obvious and user-friendly. So this is the trend followed by all the artificial scientific articles. IoT networks are being deployed in Russia everywhere. There is nothing new about that. This is just a very cheap microcontroller-based device with long waves, which is much better than Wi-Fi, which consumes less energy. Another person which we share, Riccardo Valentini, this is the person who created FlexNet, a network of towers, and this is reaction to IoT. This is like that. And the first thing which emerged, the IoT technologies, the 3-talker, which helps to somehow measure the sap flow, the spectral characteristics of the crowns of the trees using spectrometers, and at the moment this is being used in gardens or in urban areas, but this is something we have to start with. You just put that on trees, and you have up to 60 devices and one hub, which then would transfer all the information using certain communication channels to the server. The interpretation is being prepared, but generally speaking, there is much interest shown to such a technology. Moscow, St. Petersburg, Rostov, and Voronezh are in the pipeline to use that technology. If you're interested, you're most welcome. From Kharkov to Beijing, this network works, and this is just a platform appropriate not only for trees. We have certain sensors in order to measure carbon, certain technologies to prevent fire, and this is a prototype of a crop talker and a soil talker to measure the height of the plants, temperature and humidity of the soil. This is good. No, this is quite inexpensive, and the farmer doesn't need anything but to just put that on the trees, on the shrubs, but he will not analyze the data. So we need a system mentioned by Ivan Yasenev. We have such a system for the durum wheat, and we only have to streamline the data transfer from the crop talker, and we can make some assumptions and predictions, let alone the accuracy. This is only in the pipeline. If you are interested in that, our university will have a summer camp which will discuss that. And these summer camps will be arranged everywhere in Russia. If you're familiar with Russia and you do not want to spend 3 weeks traveling around Russia dealing with the soil science,